Hello, this is Paul. I'm a cinematographer, one of the creators of diachromy and diaphany. And today I wanted to take some time to, just for a quick video, to talk about the distinction between two terms that we use a lot in our videos, in our documentation, in the color science field in general. And two terms that we use a lot, and sometimes we use one for another, and obviously it's the terms look and LUTs. I thought it'd be worth the time because it really can lead to confusion, and we've heard it a lot used one for another. So let's take 5 minutes to clarify that. A look, in the broadest sense possible, refers to all the artistic and technical decisions and operations that will impact the way the image of a show is going to look like. So in a very global way, location choices, costume choices, all decisions related to what's inside a frame and the way it's going to be filmed can be included in the scope of the look. Now, obviously, when we talk about look development, we focus on the image processing aspect of the look. And so when we talk about a look in the field of color science, of cinematography, and of grading, we talk about all the choices and operations that help shape the color and texture of the images, and shaping them as a whole, as a batch, and not image per image. Image per image is, of course, the realm of grading and not of look development. In a way, you can say that a look defines the playing field of the image of a show, or the rules of the game, if you will. And the lighting, the framing, the grading take advantage of these rules to create and polish its shot within this playing field. So a look is somehow a global vision implemented on a show. There are many ways and many tools to implement a look in an image workflow. All have advantages and inconvenience, but it's not the point of this video to talk about that and list them all. Whether you're shaping the image with dedicated look development plugins, such as the one we developed at HAL Picture, whether you're just applying the same node graph to a large batch of shots in a show, you are performing look operations. You can make a look with the native tools of your grading software, and some might argue that this has limitations, that it's a bit cumbersome, that the process can be a bit slow. But it doesn't matter. It's the process of thinking the look of your images at a global level and not on a shot-per-shot basis that actually makes it a look, not the brand or the kind of tools that you're using to make it. And one of the tools that is often referred to when we talk about look development is a LUT. LUT stands for lookup table, and at the core, it's just a huge table of values that tell you, for a specific input value of a pixel, what the output value should be. So it's a large, vast pre-computed table of values. And what is pre-computed in a LUT? Well, about anything you want. It can be a color space conversion. It can be a grading operation. It can be parts of a look transformation. It can be several operations that I just described. It can be a lot of things. A LUT is a fast, dumb way to transform pixels. I'm saying fast because the fact that it is pre-computed means you don't have to redo the math of your transformations for every pixel. You just look for the closest values in the LUT and you interpolate the output values. So it's resource efficient. I said it's dumb because it is just what I said. It's a shortcut for applying math to pixels. It has no smart way to tell you in which color space to design, which operations it includes, how it is meant to operate. If the person that created the LUT didn't do a proper job of documenting it, you have no access to the intelligence behind the LUT. So a LUT can leave you with a lot of questions. How was it built? Were the math used to create it robust? Or can it introduce glitches? Was it designed for a specific camera? Or is it color managed? There is really no way to know that. And the fact that it's static and pre-computed means there is no way to revert what it does. Let's say you include a color space conversion in a LUT and that it outputs in a Rec 709. Even if you know that, there is no way to revert that operation and go back to the previous workspace without losing a lot of information. So it's fast, it's dumb. Another characteristic of a LUT is that it only conveys transformations from a pixel to a pixel. It cannot take any context as an input. So it can take the context of the surrounding pixels or the pixel before in time or the pixel after in time to calculate the value of the output pixel. So that means no spatial or temporal transformation can be included in the LUT. A pixel in, a pixel out. When it comes to look, that leaves out a lot of operations. Finally, a LUT is discrete. it samples all the possible values of the pixel in a limited number of reference values. LUT-33, for instance, which are very common, have 33 by 33 by 33 values for pixels. So that's about 35,000 values. You have LUT-65, so you have to elevate 65 to the power of 3 to calculate how many values you have in total. The most values you have, the more accurate you are, but also the bigger the file is and the less efficient it is. So what you gain someplace, you lose on the other side of the spectrum. This discrete aspect has one inconvenience. It is that you do not know how you achieve that result. You have the results, but you do not know how it got computed. And that means you cannot easily modify it. In our look tools, for instance, everything is mathematical functions, which is by definition continuous, the opposite of discrete. And one of the big advantages is that you have access to the parametric values of these functions that you apply to the image, and you can modify each and every one of these functions and these parameters independently. So at any given time, you can amend, modify, evolve your look without having to start from scratch, open a node graph, or understand what has been done that has been made static in a LUT. So that's basically the huge differences between a LUT and a look. So why is a LUT useful? Well, a common and very pertinent use case of LUTs is to perform in-camera look monitoring. When it comes to cameras, resource is very scarce because you have to process your image in real time. So LUTs are very well designed for that purpose. And all professional cameras have a way of loading and applying a LUT to the monitoring feed. So you can embed most of your color transformations of your look inside the LUT, load it in the camera, and then you get access to your look, to most of your color look, in real time while lighting and shooting your scene. For a director of photography, that is very interesting to get access to a preview of your look, some sort of draft of your look, if you will, directly in camera while prepping and shooting the shot. Of course, you don't get access to your texture transformations, which have an impact on the image, so you have to account for that, but you still get a lot of help with that in camera monitoring. But in the end, LUTs are just a vehicle, and you can put a lot of stuff in it, and it can be very useful, but it will never be a complete look for all the reasons we listed. So it's important not to use LUTs when we want to talk about look. It's important to remember that LUTs have a limited amount of use that is very pertinent in some cases, but do not cover all the requirements and the needs of a proper look development tool. And that's why we try and maintain that distinction as best we can. I'm sure you will catch us using one word for another at some point, but we really try and be as accurate as possible when it comes to look versus LUTs. So that's it. That covers what I had to say about look and LUTs. It was really just about clarifying some usage of these words and making sure we're all on the same page when it comes to what a look is and what a LUT is used for. Really as simple as that. I hope it was useful anyway. Thanks for watching.